Assalamualaikum warahmatullahi wabarakatuh. My name is ENGKU RAHAN. Today I will present about final year project proposal for FIP1. My supervisor is Dr. Nick Rosalina binti Nick Rosli. My title for FIP1 is Tribological Study of Nickel Graphene Oxide Nanocomposite Coating, Effect of Graphene Oxide Concentration. Content of this presentation: first is background of study, problem statement, objectives of study, scope and limitation of study, literature review, methodology, expected result, and project planning. Background of study: tribology. Tribology is the analysis of corrosion, friction, and wear on nickel graphene oxide. Coating: the process of forming and applying thin liquid to solid surface. A layer or layers of material deposit onto substrate to improve the surface properties. Graphene: high mechanical strength and elastic modulus, improve anti-corrosion behavior, good material for coating, and unique structure. Graphene composite: improvement in the coating hardness and thermal conductivity. Graphene combined with other material or nanocomposite coating. For problem statement: coating of composite nickel and graphene or graphene derivatives has only been recently studied by few researchers. So we got a lack of resource. Therefore, understanding on its physical, mechanical, and especially tribological properties has not been extensively explored yet. In this work, the tribological behavior of coating deposit at graphene concentration will be investigated using pin on this tribolometer. Objective of study: in this experiment we got two objectives. First is to investigate the tribological properties of nickel graphene oxide coating deposit with various graphene concentration using pin on this tribolometer. Second is to characterize the wear morphology and surface roughness after tribo test. Scope and limitation of study: the tribological test will be carried out on nickel graphene oxide composite coating deposit at graphene concentration of 0.025, 0.05, 0.1, and 0.2. The test condition will be fixed at load, sliding speed, and rotation speed of 10 Newton, 250 RPM, and 20 minutes respectively. Due to the limitation of the tribo test machine, it can only be carried out at room temperature. Deposition process need to be precisely controlled in order to ensure consistency of the coating deposition, which will influence the tribological test. Literature review: friction and wear. Friction also can be called as force that apply in opposite direction. Friction can exist between two surfaces that moving or sliding. Physically, these reaction forces are the consequence of a variety of mechanisms that are influenced by contact geometry and topology, features of the body's wall and surface material, displacement and relative velocity, and the presence of lubrication. Wear may be defined as damage to a solid surface caused by the removal or displacement of the material by mechanical action of contacting solid, liquid, or gas. Few types of wear: abrasive, adhesive, fatigue, polishing. Literature review: nickel graphene composite coating. Investigated pure nickel and nickel graphene composite coating and have shown improved anti-corrosion behavior by Quad et al. Significant improvement in the coating hardness and thermal conductivity with the incorporation of graphene, Sine et al. High wear resistant nickel coating were developed with graphene oxide incorporation by Sine et al. Nickel graphene coating have outstanding tribological behavior in comparison to pure metal coating. Nickel graphene have high hardness, wear resistant, and solid lubrication properties. Figures show carbon weight percent distribution in nickel graphene oxide composite coating. Mechanical properties of nickel graphene coating. The nickel and nickel graphene layer were obtained successfully, and uniform coating were obtained at 3 samples: titanium nickel 1 graphene, and titanium nickel 10 graphene. But the layer of titanium 5 graphene is not uniform enough. The microhardness is increased by increasing the graphene oxide from 5% to 10%. The microhardness value increase when concentration of graphene oxide increase. Figure or show obtain surface microhardness. Tribological properties nickel graphene coating. Pure nickel will have higher wear rate than the nickel graphene composite coating that consists lesser wear rate. By adding graphene in nickel was found to reduce wear and low friction. Wear on nickel graphene coating surface lead to the exfoliation of graphene from the coating, allowing the nano-sized particle to enter asperity contact and reduce the friction coefficient. When sliding speed increase, coefficient of friction and wear decrease. Electrode deposition process. Electrode deposition is one of the most essential methods for creating metal matrix composite coating from L. Zhang et al. The electrode deposition process was performed to prepare the nickel graphene composite coating. The substrate connected to the negative terminal while an electrode is connected to the positive terminal to allow the current passing through. Electrode deposition is the best selection when compared to the other method due to its simplicity and speedy result. Methodology. First, we will start by preparation of substrate mild steel plate. Second is preparation of solution with different graphene concentration. Third is electrode deposition process. Fourth is friction and wear test using pin on this tribometer. For characterization of material, we will use X-ray diffraction machine (XRD). Second is scanning electron microscope (SEM). Third is Alicona infinite focus. For all the result, we will analyze it. Test parameter. Coating will be deposited at graphene oxide concentration between 0.025 gram per liter to 0.2 gram per liter. We got 4 samples. Sample 1 we will use 0.025 gram per liter. Sample 2 we will use 0.05 gram per liter. Sample 3 we will use 0.1 gram per liter. Sample 4 we will use 0.2 gram per liter. Load we will fix at 10 Newton. Sliding speed we will fix at 250 RPM. Duration we will fix at 20 minutes. Expected result for this experiment is the graphene oxide concentration will alter the coating deposition and the physical and mechanical properties of nickel graphene oxide composite coating. Thus will also affect the tribological performance. The outcome of this work will contribute to the understanding of tribological behavior nickel graphene oxide composite coating when fabricated at the different graphene oxide concentration. This is my project planning begin in late 2021 and end in 2022. That's all for my presentation. Thank you very much.